Okay, hi folks, this is lab 10 of week 10, and for all of you, all 10 of you who were present in the lecture yesterday, I said that these problems that you have to write a code, there is an alternative way of doing it, and instead of writing a C program, you can actually specify the sketches which replicate those rules and use it to basically uh, employ the simulation with laws. However, yesterday I said that I'm not going to do that this semester, but after I thought about it, I decided to eat my words, and I'm going to change my mind, and I will show you how to do these things with sketches. So that is what we're going to do today, okay, in the lab. On the test, if you have a problem, unless you're specifically told to use, for example, a C program in order to specify the motion, you have the freedom of using the sketch-based rules if you want to do that. So the two items on the agenda are sketch-based rule instead of C programming, and then the last few minutes I'm going to talk about the concept of parameters, defining parameters in CATIA and displaying it in the tree. Now, remember, we have 2 more weeks of classes left, and during these 2 weeks, I will be using this issue of parameters and design table, etc. The semester is not over. We still have 2 weeks left. All right, so let's move on. This is the one that I did on class on Tuesday. We have a block that is traveling along the line, and this is the rule, the one above, the one right on top is the rule that it's supposed to follow. In other words, the first 3 seconds, it should stay where it is. Then between times 3 and 7, the velocity, the position is going to increase because there will be a velocity imposed on this block. And then when it, after 7 seconds, it stops at that location, which is 5 inches away, and then it goes back according to this velocity, which is basically it is 5 inches over 3 seconds backward. Now, it is possible to use this sketch exactly like it is and go that route, but I'm going to do it a different way. So what I'm going to say is that, look, why don't we normalize this curve? Normalize this curve so that the height is 1. So all I have to do is to take all of these things and divide it by, this is a mistake, it should be divided by by 5, not by 6. Divide by 5, okay? So if you take this and divide it by 5, the height of it goes between 0 and 1. And normalize the scale, horizontal scale, so instead of going from 0 to 10, it goes from 0 to 1. So it is this curve, actually, that I'm going to create in my CATIA program and tell the software that you should follow this normalized one. Of course, when you do that, you have to tell it that there was a scaling involved, namely a scaling of 5, so be aware of that, okay? So let's go ahead. Let me assume that the length of this whole thing is 8 inches and the block is 1 by 1. So that I have a better feeling of how things are going to go. So insert a new part in there. I'm going to call it the track. I'm going to call this thing a track properties. Track and track. And say, okay, let's make it. It's a very simple part. It's just a box, basically, 8 inches long. So on that vertical plane, I'm going to sketch something that is going to represent that track. So the rectangle, something like this, no problem. let me just put a width of 1 inch here so that I know exactly what's going on. Yeah, so let me make this thing 1. All right, exit. And I'm going to pad it by 8 inches. 8 inches. Okay, so that's the track. Then I'm going to insert my block. So insert, a new part in there. Say no, and make this thing the block. Notice that what I've done is I've inadvertently selected the tree, so either you put the cursor on one of these white lines in the tree and click left click, or you can just click this axis system down here, okay? So let me rename this thing, properties, call it block, and block. Okay, it's just a box. 1 by 1 by 1, for example. So on that vertical plane, I will sketch. Okay, so something that looks like that. Why don't I give it some dimensions? So this width, I want it to be 1 so that it fits that track. Okay, now you don't have to. This has nothing to do with fitting it the way you may think. But anyway, I'll do it like that, and I exit and pad it by 1 inches. One. Good. So let's go all the way to the top. All right, before I go any further, this curve needs to be inputted somehow, either as a sketch or as a curve in space. Now, I suggest sketch, okay? So this is a sketch that has nothing to do with my part. The only reason I'm putting it there is that I want to use it later on to use it as my rule, okay? So here's what I'm going to do. Go back here. And it's entirely up to you where you want to put it. You can put it as a separate part, or you can put it in track, or you can put it in the block. You know, what I'm going to do is I'm going to make a separate part. So insert a new part in there. This is just so that we can see how things are going. Right-click properties. I'll say sketch holder. How about that? Sketch holder. I could have put it in the block or in the track, sketch holder, but I'd rather put it in a separate part, a part of its own. Those of you who know a little bit more, this could have been done in the form of a geometrical set too. You can put it in a geometrical set, but let's not worry about that. Double click on the sketch. Actually, what I meant to say was a sketch holder, actually. Let me change that. Right click so that you don't get confused. Properties, sketch holder, sketch holder. Okay, good, good. So on a convenient plane, whatever you feel comfortable with. For example, let me put it on this vertical plane. It doesn't have to be there. It can be in any of these other planes, but I'm going to say, okay, sketch. Okay, I have to draw something like this. Horizontal to some value, back down. So let's go do that. And so let me go and draw a profile like this. It doesn't have to start at 0 either. Like that, going down, and we're good. Now let's put some dimensions that reflects this. So I'm going to say, okay, dimensions from here to here, 0.3, okay, from here, well, actually, let's do it like this. Let me cancel that. From here to here, horizontal, right click horizontal. This is going to be 0.7. Is that right? Let me see. What was it? Yeah, it is 0.7. 0.7. Okay. And finally, from here to there, 1. And what about the height? The height from this peak to that line, remember we normalized it? Meaning that I made sure that this peak is at the height 1. Right, so there's my sketch. And I'm going to be using this for that rule in a minute. Exit. Good, so here's my sketch, the sketch that I created. That's the sketch for using it as a rule later on. Let's go all the way to the top, create our assembly constraints. So anchor the base, coincidence between this edge and that edge, and coincidence between the side face and this side face. Or you could have done the bottom of the block and the top of the track, and update. So this is going to turn into a prismatic joint. Let's go to the digital markup, DMU kinematics, get the magic wand, new mechanism, okay, auto create, okay, let's check it out. This is going to be a prismatic joint with degree of freedom equal to 1. Good. Double click on this, make it length driven, but I want it to go in the other direction. We'll flip that blue arrow. Okay, good. Now remember, I'm going to use this, okay? I'm going to use this sketch. If you don't like it, you can hide it, but I'm going to need it because I can get it from the tree also. Right there, it's right there. So that's the dummy, that's the sketch, normalized sketch. Okay, so let me see now. Yeah. So here's the way we're going to do this. There are different ways of doing it, but here's one way. You go to command right there. Double click. This thing pops up. There is a box here which says link. You see that? Link. You click on it. It says, oh, where is that sketch? See, it's saying select the sketch you want to link to the command. Now, I can do it either from the tree, select this, or I can do it from here. And it says, what is the maximum time? The maximum time for me is 10. Remember I normalized it to 1, but I have to tell it what the maximum time is, 10. We say OK. A new kinematic has been successfully created. We say OK. Now, how does it know that the height, though, should be scaled up by 20 because this height is 1? We say OK, no problem. We go. Notice that in the tree, underneath that sketch, something called a law has been created. If you double click on it, you see, one more time, right here, it says, what is the scale? The that you want for that to be applied to. And now this scale, see that? The answer is 5. Remember I divided by 5? Good, good, good. Now, I have a suggestion. Do not fool around with this heterogeneous law. Do not fool around. I'm going to show you what it is, but I'm not going to use it. Notice that if you selected this, then you can go and select different units, because pretend that I wanted actually not to normalize. I wanted to put the height of 20. Well, that height of 20 is going to really give this guy a headache when it comes to viewing it. So you can do things like that, but I'm not going to do it. I do not want this thing to be checked. Okay, just put down the scale that you use to reduce the height of 5 to 1, and that is 5. You say, okay, we are done. No more writing the code. So back to the digital markup. Right there. Let me also close these because I don't need them. Just take some real estate here. Okay, good. So we're going to do simulation with laws. Simulation with laws. Okay. Remember, I showed you in class on Tuesday that you don't have to create a sensor if all you want to do is to make sure that this curve was inputted correctly. You can if you want, but you don't have to. Just click on the activate sensor, and there are no sensors, but it shows you what your command is. This is the thing that I want to plot. So you say yes, select it, play it. 3 seconds, stays put, right? 3 seconds, stays put. And now starts moving up to some location based on that plot, and then it goes back. It goes back. The reason it's too slow is that I changed this number to 200 and I didn't change it back to. Okay, now if I graph this, I better get that original plot right there. You see, up to 3 seconds, stays put. Then up to between 3 and 7, it goes all the way to height of 5, and then it drops down, goes back to 10. Okay? So that is the first problem that I'm showing you how to do the problem using a sketch instead of a rule. We did this problem by me writing a rule using the if time is less than 3, then ... etc. So this takes care of that. We're done here. We're rewinding. Close that. And I'm going to do my second problem. Well, let me close this too. I don't need it. Okay, so the second problem is that racing block. I did this thing on yesterday, but I wrote 2 rules. One rule for the block one, the green one, one rule for the blue one, and the reason I did it as 2 rules is that these breakpoints are different. If the breakpoints are different and you try to write everything in a single rule, there's going to be a lot of if statements there. Okay, so I did what I did in class yesterday. There was a green rule that I wrote. There was a blue rule that I wrote, and then did the usual. Now I want to non-dimensionalize, normalize these things, these heights, so that it goes to 1. This way it goes to 1, and draw those sketches as dummy sketches in my CATIA part, and then use it for linking purposes. And we'll do that. Okay, so just keep in mind that I'm going to make a track, and 1 blue block, 1 green block, but since the actual dimensions go up to 20 inches, so I'm going to make the track 22 inches long, and then these blocks 1 by, something. All right, so let's go ahead and start. Where is this? So we're going to be product, and I'm going to take my chances, not do any save. This is a bad idea. So insert a new part in there, and I'm going to call this thing track. Right click properties, track, and track. Okay, let's go make it. So on that plane, I will sketch. Why don't I make it something like that? Let me give this thing a dimension so that I have an idea what it is. So let's make it, I don't know, 3. Totally irrelevant. And then pad it by 22 inches long. Okay, there's my track. And then I'm going to insert the blue block, insert a new part in there. Going to call it blue block. Right click, sounds like blue blood. Properties, blue block. Blue block. And blue block. Double click on it. On that plane, on that same plane, I will sketch. Okay. Like that. Okay, why don't I make this thing 1, by the way? The actual height doesn't matter. Well, 1 and 1. How about that? So 1 and 1. This is going to be 1. And this is going to be 1. Okay, exit. Okay, pad it by 1 inch. We can do the assembly constraints later on. Let me change the color here. Right click properties. Change that thing to graphics, blue. Okay, good. So all the way to the top. Insert a new part. Call it green block. Properties, product, green block. We can do a current copy and paste here, of course. Copy, paste. Say okay. Let's go make it. Double click on it. On that vertical plane, I will sketch. Okay. 1 by 1. This was 1. And this was 1. Okay. Exit. Palette. 1 inch. And I'm going to change the color here. Put the cursor there. Right click. Properties. Graphics tab. Change the color to green. Okay, good. All the way to the top. Now we need to create these 2 sketches, right? These 2 sketches, the non-dimensional one, I have to do that. So what I'm going to do is I'm going to create a part just so that it's easier for me to manage things. So insert, new part. Its sole purpose is to have 2 sketches in it. Right click properties, sketch holder. This is just a name, right? You can call it whatever you want. Sketch folder. And again, copy, paste it here. Say okay. There we are. And now let's do the blue sketch, the blue rule basically. So let's go to the part design first of all. Part design. On a convenient plane, you decide where you want to put these sketches. So I'm going to do exactly the same thing that I did before. On that vertical plane, I will sketch. Okay. It doesn't matter where you put it, but this is the blue one. It should look like this. okay, with these relative sizes. So let me go ahead and this is the blue one. I'm going to change the name of that, by the way, to blue sketch. Okay, so it goes like this, right? It goes like that. Okay, good. Let's look at this thing for a second. So 0 to 0.3 and then 0.5. Okay, so just keep that. This is the graph that we have here. Let me dimension from here to here. That is 0.3. Okay. From here to here, horizontal distance. Okay, this is 0.5. 0.5. I think the other one was 0.9. Yeah. So dimension from here to here, horizontal distance. This is going to be 0.9. And the last one is 1. So dimension from here to here, horizontal 1. And the heights I have to take care of. Let's see now, the first height is 0.25. Then this one is 1. 0.25 and 1. Okay, so let's go back there. So dimension from here to here, that's going to be 0.25. 0.25. And then from here, this top point to this is going to be 1. Yeah? 1. So this thing that you see here is supposed to be that. Okay? Now, this is the reason that I said, see, if depending on the size of the part here, you may decide to, normalize it or use a different scale, etc. Because the scale you can specify later on in that dialog box that I showed you. Okay, so this is exit. Hopefully I didn't make a mistake here. Okay, good. Let me call this sketch blue rule. Let me see now. Properties. I'll say blue block rule. Okay, it's just the name. Okay, that's the name of the sketch right there. Good. Now I'm going to do another sketch, and that other sketch is this green one. So I'm going to select the same plane and sketch on it. Okay, I'll do it right next to this so that I can see it. Now remember, these are in different sketches. Do not get the impression that this is in the same sketch. This is a different sketch. But I need something like that. I think it was like this, isn't it? I can't remember. Hang in there. Is that what I had? This, and this. Yeah, that's the green one. That looks good. So let's do some dimensions here. From here to here, the horizontal distance is, I believe it is 0.2. Yep, this is 0.2. Okay. Then from here to here, horizontal distance, and I believe that is 0.5. 0.5. And finally from here to there, that's 1. And now the heights. It goes from this is 0.25 and that guy is 1, right? Okay, very good. So dimension from here to there, that is 0.25. Okay. And from here to here, the vertical distance is 1. There we are. So what I have done, exit. Let me change the name of this so that I can easily find things. So properties, I'm going to call this thing green block rule. I could have left it sketch 1 and sketch 2 as long as you don't get confused, but that's okay. Very good. So now, these could have been anywhere, in any plane, as long as you have shape like that, okay? It's amazing how much freedom you have to do things like this. Now, okay, so let's go all the way to the top, okay? And go to the assembly design. First of all, anchor the track. Okay, good. Coincidence between this edge and that edge, and coincidence between this plane and that plane. Update is going to bring it down. That will become a revolution later on. Let's do the other guy. This edge and that edge, and coincidence between this plane and that plane. Update. Excellent. Good. Pretty much it. So now we're going to go to digital markup, VMU kinematics, magic wand, new mechanism, auto create. Needless to see, there's going to be 2 prismatic joints right here. Both of them are going to make length driven. Same thing here. The direction, I'm going to make it sure it goes that way. The other direction. I think I didn't do the other guy. So double click, click on it so it goes to the left. Say fine, no problem. All right. Okay, so there are 2 commands here, right there. You can see that. I'm going to do the first command, this one. This is the, I can't remember which one was it. This. First I did, so this one is for the green one, and this one is for the blue one, I'm sure. If I I'm pretty sure this one was free for the green one because I did this guy first. Double click, link. Now select that green sketch, time is 10, no problem. Now do the other one, double click, double left click, link to the blue one, time is still 10. Say okay. And notice that in that dummy part, sketch holder, some laws have been created, and you can go and specify the scale. If you go double click on this, you can do it here, or what I showed you last time was I double clicked on the law, okay? This opened up. But if all you want to do is to change the scale, I could have clicked on this. Now, this is going to be a scale of 20, right? I divided everything by 20. That was the actual movement, divide everything by 20. And the scales can be different, by the way. They don't have to be the same. So which one was this? That was that was this guy. And law 2, also the scale is 20. We say okay. Go back to your mechanism, which was here. Go back to the mechanism. Yeah. Simulation with laws. Activate sensor. Notice that there are 2 things that I want to plot. One is the command for the blue one, the other one command for the green one. They better give me those plots. And then play it for 10 seconds. These are the blocks racing, right? Good. Graph it. Oh, you know what? I forgot to say, get me these. Yeah, rewind. Clear the history. There's no history because I didn't ask for it. You have to select this, turn this thing into AS, turn this thing into AS, play it. The reason it's so slow is that I put this number 200 there. Graph. This better be these two put together. Okay? And they are. They are. Believe me. Okay. Believe me. Okay. So let's go ahead and get rid of that. Get rid of this. It's entirely up to you how you want to do these problems. Write the code, or this is another way of doing it. So what I want to show you now is that there's a little bit more. Yeah, we're done with this. I just showed you these things. Oh, by the way, these are the steps for guiding you through linking it to the appropriate curve. And then you double click on these guys open up. Okay. Put this proper scale. Yep. Okay.